All right, we're going to go over problems 16 through 20 on the exam. Let's start with number 16. Which statement regarding correlation is not true? Well, before I give you the answer to this question, a couple things I'm going to want you to write down. When I put a red mark right here, I want you to write that down. I want you to write down this next thing. So the first thing, when two sets of data are strongly linked together, we say that they have high correlation. And correlation can be positive or negative. You can have strong positive or strong negative. So looking down at this little chart, you don't have to draw this whole chart. So right here, you don't have to draw that, but I do want you to look at it. To give you the idea of perfect positive correlation all the way down to no correlation, then perfect negative. So an example of positive correlation, or maybe high or perfect positive correlation, is if you look at, for example, let's see, if you let's see, the more, well, let's look at this. Calories. Let's just say the X is calories in. So in other words, food you eat and weight. Right? That is going to result in positive correlation. Now, for some people it might be a little bit different, but in general, it's going to be a relationship that as the calories in go up, so as the calories in go up this way, the weight is also going to go up. All right? So that would be positive correlation. Another example could be hours studied. So hours studied, or hours studying, something like that. Hours studied. And test score. So if I were to graph a number of students and I asked them, how many hours did you study and what was your test score? In general, you're going to see as the amount of hours goes up, the test score would go up. Now, it wouldn't be the case for everyone, but in general, you'd see most likely a positive correlation, right? Strong positive correlation most likely. Now, what about negative? So I have my axis here, and what if you have, let's think of something that's negative correlation. As X goes up, Y goes down. Well, let's see. Well, let's use weight and exercise maybe. So let's do hours exercising. Don't do spell check on me. Hours exercising and weight. In general, that is going to be, that's going to have a negative correlation, because the more you exercise, the less your weight's going to go, or the less your weight's going to be. So it's going to go down. In general. So in general, it would have a negative correlation. I know there are other factors involved, but in general, you're going to see a negative correlation. I'm sure that you can think of other ones on your own. But based on all that, let's look back up at the examples, or not the examples, the answers. And the possible answers, if you read through them, our answer is definitely number 3. It says, which statement regarding correlation is not true? Well, number 3 says a negative correlation coefficient indicates that there is a weak relationship between two variables. That doesn't mean that at all. You can have, let me see, correlation coefficient. Let me go over to this website also. Okay, I have to, I'll pause this for a quick second. Okay, I came back here and just looking at this information here, you can have a correlation coefficient anywhere between 1 and -1. Actually, I'm going to go back to smartboard now. And actually, the information really right here. It can be anywhere from 1 to -1. That's your correlation coefficient. You can also find that if you have some, like a set of data, and you put it in the graphing calculator, you can actually get the correlation coefficient. And it could be anywhere from 1 to -1. But -1 would be strong negative, or perfect negative rather, and 1 would be perfect positive. So when you look at answer number 3, that is not a true statement about correlation. All right, let's look at number 17. All right, first of all, I want you to write down a couple of things. I want you to write this down. This symbol that you see here is called sigma. It's summation notation. So I want you to write that down. And we're going to look at an example. So I want you to write down this example. And at the bottom here, just a little example of what to do when you see this notation. And then we'll go over our question. So go ahead, you can pause it, write that stuff down. I'm going to pause it myself. All right, back, and let's look at this example. All right, got a couple things here. So if you look down at the bottom, right here, on this example I had you write, or this, that's kind of a way of, looking or what to do when you see summation notation. So what you do is you start at this value, just like you see this arrow. So this is going to be your starting value at n equals 1. You're going to go to this value up here, which is 4. What you're going to do is then add up each term. So when you plug in 1 here, you're going to get 2 times 1 plus 1, and that's equal to 3. Then you're going to go ahead and you're going to plug in 2. So now you're going to go and plug in 2 here. So 2 times 2 plus 1 is 5. Then you're going to plug in 3. And you're going to get 7. And then 9. So this is going to give us a value of 24. So coming up here, a little bit more difficult because you have cosine involved. But you still are going to start here. Start. Finish. All right, so we're going to plug in those values into the end. So our first one is going to be cosine of 1 times 5. So 1 times 5 all over 2. So that's really the cosine of pi over 2. All right, this goes perfectly with what we've been doing on the unit circle. What is the cosine of pi over 2? Well, look on your unit circle, pi over 2. Our cosine is going to be our x value, which is 0. So our first value we're going to add up is going to be 0. Plus. Now we're going to plug in 1. I'm sorry, now we're going to plug in 2. We just plugged in 1. Now we're going to plug in 2. So now, erase all this, and we're going to plug in 2. So cosine of 2 pi all over 2. And that's going to really be, cancel that, that's 1. So that's really just the cosine of pi. And if you look at pi, that's going to be over here. What's the cosine? -1. So we have 0 plus -1. Now we're going to do the cosine of 3 pi over 2, because we're going to plug in 3. So cosine 3 pi over 2, that's coming down here. So we went to 90, 180, now we're down here. And our x value is 0, so plus 0. So what's 0 plus -1 plus 0? That is -1. Okay, here you have a quadratic equation. It's kind of hidden, but not really. You have b squared. This is your highest power right here, x squared. So what I would do is set this all equal to 0, look at my discriminant, and that's going to tell us what the roots of the equation are. Are they real, rational, and equal, imaginary, or, we can figure that out. So I'm going to multiply all this out. I'm going to get 4x squared minus 4 is equal to 3x, negative 3x, sorry, And I want to add 3x on both sides. Put this over here, so I end up with 4x squared. I'm going to put the 3x in between to put in standard form, so it's going to be plus 3x minus 4 is equal to 0. You guys remember the discriminant? That's b squared minus 4ac. And remember, this is our a, this is our b, this is our c. So I'm going to do 3 squared minus 4 times 4 times negative 4. And you get 9 minus 4 times 4 is 16. So minus a negative 64. So that's really 4 to the third. 4 times 4 times 4. Yep. Minus negative 64. So that's really 9 plus 64. And that is going to be 73. 73. Okay. So that's our discriminant. That tells us a lot. I've talked to the class a lot. If this had been a perfect square, we would know our, first of all, we know that this was factorable, but it's not. 73 is not a perfect square. So that tells us that this was not factorable. It also tells us that we have irrational solutions. Because the only way you have rational solutions is if your quadratic equation was factorable. Since it's not, we know that we don't have imaginary, because that would mean the only way you'd have imaginary is if you got a negative for your discriminant, which we do not. It's not going to be rational because we have 73 as our discriminant, so our answer is number 4. All right, looking at this one, if f of x equals 2x squared minus 3x plus 4, then f of x plus 3 is equal to which one? Well, if it said f of 3 is equal, well, we would just take 3 and plug it in here, and we get 2x, I'm sorry, that's x, 2 times 3 squared minus 3 times 3 plus 4. So that'd be easy. You know, we'd have 2 times 9, 18 minus 9 plus 4, and we'd have f of 3 equals something. But we have f of x plus 3, so it's the same concept. So f of x plus 3, you just take the entire x plus 3, and you plug in x plus 3, the whole thing here, and right there. So we're going to have f of x plus 3 equals 2 times x plus 3 squared minus 3 times x plus 3 plus 4. So we end up with, let's see, equals x plus 3 squared is, so you got to do your exponent first, so we're going to have 2 times x squared plus, we'll probably smart board, plus 6x plus 9. I didn't show all the steps there, so hopefully you understood that. And minus 3x minus 9. Be careful, you're distributing this negative 3 here and here, and then plus 4. All right, now we still have to do the 2. So this is equal to 2x squared plus 12x plus 18 minus 3x minus 9 plus 4. And we have this squared, got that, so equals, so we have a like term here, so we have 2x squared plus 9x right here, like term, so 18, 9, and 4, 18 minus 9 plus 4, 18 minus 9 is 9, plus 4 is 13. So hopefully that answer is there. If not, I'll go back and check my work. 2x squared plus 9x plus 13. And that is answer number 3, and that is correct. All right, here's the last one, number 20. I want you to write down these little charts, or this chart. right here, and these other examples. We're going to need it for this problem. So take a second to write those down and pause it. This chart's going to be very helpful to remember. All right, and if I'm dealing with the expression I'm dealing with in this problem, just remember only the 3i to the second power squared is raised to the third power. So that's going to be x times, now 3 to the third is 27. I squared all to the third is really I to the sixth. And there's no power number here, so that's plus 2x I to the 12th. Well, if you look on the chart, if you notice, I to the second is -1, I to the fourth is positive, I to the sixth is negative, I to the eighth is positive, I to the 10th would then be negative, I to the 12th would then be positive. So this I to the 12th is all equal to just 1. And this I to the 6th, we can look right on the chart, is equal to -1. So we have 27, 20, so I'm going to rearrange this as 27x, and it's all multiplied by -1, so I'm just going to make that negative, plus 2x. And if you do -27x plus 2x, you get -25x. So that is it. Hopefully we'll have the last 7, because there's 7 more multiple choice questions, and I have those for you next week. So that's about it.